Hey guys, so welcome to your first lecture for Chem 100. Again, I am Dr. Kate Hayden. Hopefully you watched my introduction video before starting, but if not, that's okay. You can always go back later. So in this unit, we are focusing first on chapter 1, sort of helping us sort of define what is chemistry, what is science, the scientific method, as well as begin exploring some basic mathematical skills that you'll need for success in this course. So as I mentioned, the learning objectives for this unit is to be able to define science and chemistry, identify and describe the activities that are part of the scientific method, identify strategies that are effective for learning while also developing a study plan for learning chemistry, reviewing math concepts used in chemistry, such as identifying place values, using positive and negative integers, calculating percentages, solving equations, and interpreting graphs. So I teach this class in a very interactive way, mainly because we learn more through doing than we do from reading or listening, although all of those things are important, right? The most effective way to learn is to read, see, hear, and do. So for example, Benjamin Franklin is quoted, tell me and I forget, teach me and I remember, involve me and I learn. So the involving you is something that is completely up to you. I can't force you to intentionally interact with these videos, although I do try to provide as many opportunities for interaction, questions, discussions as I can. Whether or not you utilize those resources is completely up to you. And the one thing you do want to be mindful of is we are compressing 15 weeks of chemistry into 4 weeks. So it is going to be intense. And the more you do, the more effective and efficient you can learn. So do not wait till the last minute to do everything. Do things throughout the day, throughout the week. And try to be as present and mindful as you can. So turn off your cell phones, turn off your email notifications, and let's get down to learn. All right. So again, we tend to remember our level of involvement, right? And so the more the lower the bottom of the triangle here, the more we can learn and retain, right? So we only remember about 10% of what we read, 20% of what we hear, and 30% of what we see. So a typical lecture is only going to get you about halfway there. However, you will retain about 70% of what you say. What this means for you as a student is participating in the discussion boards or finding a study partner and talking things out with that partner, or even tutoring, right? So that is what's going to really help you there, is if you can summarize what we've talked about and then say that back to somebody, then you're going to be hopefully remembering a lot more and working through this material more efficiently. And then we do retain about 90% of what we both say and do, right? So practicing problems, doing the in-class or in-lecture questions that I will present to you. And then, doing even additional problems in the lab experiments, right? All of those things are doing things, right? Those are hands-on learning. That's where we dive into the active learning domain, and that's where things really begin to stick versus the passive learning domain. All right, so always ask yourself, am I actively learning or am I passively learning? So when we think about studying and learning in general, we can apply those principles to studying and learning chemistry. And so the study cycle is a great sort of model to think about when you think about studying. So before lecture, you should always preview the material. Maybe that's going to Canvas and looking at, okay, what resources are available, looking at the chapter material in the textbook, and looking at sort of the bolded keywords or the key learning objectives at the start of the slide. Having those in the back of your mind as you move through the material, again, can help you recall, oh, this is an important piece, or this is how this aligns with the learning objective. The second step is to attend. Now this is online, so what attend means is that you're actively watching the lecture video just as if you were in class. So get out a notepad, um, take notes, jot down questions, post your questions to the Muddiest Points discussion board. I'll have one of those for every unit, and that is a great way to ask questions as if you're asking them out loud in class. You can even pause the video and ask your question in the moment. If I'm near the computer, I will try to respond as quickly as I can, okay? And maybe your peers can respond faster than I can. So peers, I do encourage y'all to respond to each other's questions if you are confident in your answer. Even if you're not confident in your answer, I would encourage you to respond, but please put a disclaimer of, I'm not sure, but I think, right? And that is a great way to help continue the discussion. And it also helps me sort of understand what are points in the lecture or the material that we're struggling with so that I can maybe create a specific targeted video that will help us dive deeper and clear up any of that confusion or misunderstanding. All right, so please, please, please actively attend the lectures as if you were in class, okay? And review. So after you've watched the lecture video and you've done some of the homework problems, go back and review your notes, fill in gaps, develop new questions, right? That should only take 10 or 15 minutes, but it is so helpful. And then don't forget to study. So schedule several focus study sessions per class each week. Remember, guys, we only are here for 4 weeks, so you have to be very intentional with sticking with your study plan. It is going to go by so fast. And then check, right? So can you teach this material to someone else? Find a friend, find a family member, find a dog or a cat, and try to teach it to them, okay? Or just talk it out with them. Better yet, if y'all live near each other, I can even create a discussion board for y'all to create study groups. We can create online study groups. Y'all should have access to Zoom as well, and so maybe y'all can create some Zoom study sessions so that you can do some study groups, okay? So again, study cycle, memorize it, live it, love it. It will be super helpful for you guys. That in mind, there are a number of resources within your online or e-textbook that is available to you. The periodic table is in the inside front cover. You have tables all throughout that are like conversion tables. I'm not going to ask you to memorize conversions. I will provide that for you. Looking ahead, that's a really great way when you're thinking about preparing for the lecture. That's at the beginning of each chapter. The learning goals are also the beginning of each chapter, as well as my lecture slides. There's always a review section at the beginning of each section that is like, okay, was there important information that you should already know before you tackle this new stuff? That's all right there. You have key math skills are typically in the margins along the chapters, as well as core chemistry skills. Key terms are bolded throughout, and then don't forget that glossary index at the end of your textbook. Because we're using masteringchemistry.com for our e-learning, for the in-class or in-lecture activities as well as for homework, your textbook is integrated into Mastering Chemistry. So all of these tables and periodic tables you can pull up at any time. And there's interactive videos as well. So not only my videos and the supplemental videos that I post on Canvas, but also videos in Mastering Chemistry that are very like targeted to the course content that might be helpful. It's always great to see the same concept through lots of different perspectives and lenses. Again, that's just going to give you a more dynamic understanding of the material as we move through the course. So why don't we go ahead and log in to our Chapter 1, Part 1 in lecture activity. And this is by going through masteringchemistry.com. So really quickly, I'll show you how you can access that. If you go to our course Canvas page right here, you're going to click on My Lab and Mastering. Now, if you haven't purchased the license yet for this, now remember this includes both our homework, our in-class activities. This is how I'll be giving exams. And your textbook is all right here. So if you haven't purchased it yet, it will probably say, you need to register and purchase. You can do that right here. Once you've purchased it, it should look something similar to this. You may see some different things just because I'm on the instructor end, but you're just going to click this link and it's going to open Pearson. Again, yours may look a little different, but you should see sort of assignments that are coming up due. You can toggle through all the multiple assignments. Another great thing is to maybe look at the calendar perspective, and you can sort of see which assignments are due when. And you can also look at the list of assignments. All right, so there's a lot of assignments that are already available. You'll notice some roll out at different times, so you may not see all these assignments that I see. So again, the first thing we're going to look at is Chapter 1, Chemistry in Our Lives, Part 1. And when you open it, it should look like this, right? So you should see all the questions and your current score, when it is due, and then the late policy. All right, so it said, let's do number 1. So we're going to click on number 1. And we have a question here. How will each of the following increase your chances for success in chemistry, right? So you're just going to answer these questions. Sorry about that. And then when you're done, you can hit submit and it will automatically check your answer for you. You have unlimited attempts, so you can get the question wrong and try again. If you find yourself spinning your wheels, you have attempted the question 20 times and you cannot figure out what the right answer is, usually it's just a technical glitch, so please email me and let me know. I can always go back in and adjust grades, so don't panic. The point for these in lecture questions is to, again, keep you engaged and intentional with moving through the material. It is not meant to trip you up or to make you fail or anything like that. These should be easy class participation points, and you do get credit for doing these assignments. So this is the padding, right, in your grade. That's going to allow you to maybe struggle with a test or miss a homework and it not majorly affect your grade. But it is only padding if you do it. Okay, so please make sure you do complete these assignments on time. All right. Okay, so once you have completed the question that you are asked to complete, then you will go back to the lecture video and move forward. Okay, so we answered question 1. Now, I want you to take a minute and devise a study plan using your template to tackle Chapter 1. And then navigate to our course Canvas page and share your plan under the discussion board study plan, right? So again, we are going to go to our course Canvas page. I'm going to go home. I'm going to go to the first module, Chapter 1, Part 1. First off, you'll notice here is that weekly study plan and study tips PDF. And so you'll notice it's printable. Here it gives you some study hints or tips. And then here's your weekly study plan. Okay, so you notice you can sit here and write in, all right, Monday I'm going to do this, Tuesday I'm going to do this, Wednesday I'm going to do this. So again, go back, look at the lecture schedule, look at the lab schedule, ask yourself, okay, when do I need to do what when, what's due, all of those things. Because again, 4 weeks goes by super fast. We need to be intentional. All right. Once you sort of devise that study plan for just this week, then I want you to go to the discussion board here and write down, okay, how am I going to meet both the responsibilities for this course as well as my other competing responsibilities in such a way as to maintain a healthy and balanced lifestyle while being successful in this course. All right. So once you've done that, unpause and come back to our lecture. all right, which is right here. Okay, so continuing on, chemistry is a foundational discipline. It overlaps with so many other scientific disciplines, from physics, when we think about the thermodynamics of chemistry reactions. A lot of it is driven by physics, biochemistry, right? The human body, physiology, all of that is chemistry. Those are all chemical reactions that allow us to grow and breathe and thrive. Astronomy, right? We have chemistry that's going on in the stars and the universe and planets. Medicine, right? We can't have medicine without chemistry. Plant science, biology, environmental science, geology, all of these things have foundations in chemistry. So chemistry is such an important discipline to understand, not only because it's super interesting and atoms make up everything in the world, but because it is foundational to so many other scientific disciplines. So what is science? So science is the process of seeking and understanding of the underlying principles of nature. It involves two facets: technological or factual, and philosophical or theoretical. Technology, therefore, is the direct application of scientific knowledge in order to solve problems, right? So the technology is the so what of science. But we can't have technology without basic foundational science. Chemistry, therefore, is the study of the composition, structure, properties, and reactions of matter. And it happens all around you every day. Great example, think of an antacid tablet that undergoes a chemical reaction when dropped into water. So if chemistry is the study of matter, well, obviously we probably need to define what matter is in terms of chemistry. So matter is another word for all substances that make up our world. Anything that takes up space or has mass. And we can subdivide matter into two categories. It can either be pure substances, which are comprised of either pure elements or compounds, or matter can be comprised of mixtures. And in mixtures, we can have a homogeneous mixture where you have more than one element or compound mixed together evenly, or heterogeneous mixtures, right, where there's clear divisions between the two elements or compounds. And we'll revisit this later on in the semester, but I just wanted to make sure we sort of had this basic understanding of what is matter. So, well, what matters not? So, is everything a chemical? No, not everything around us is a chemical, but everything that is made of matter is a chemical. If it does not contain matter, meaning if it does not take up space or has mass, then it is not a chemical, right? So we can think of chemicals as molecules and cats and gases. But what is not a chemical? Well, that's things like forces. So heat is not a chemical. It's a form of energy. Thoughts, right? The thoughts going on in your head, that doesn't take up space or has mass. And then the force of gravity, right? All of these things are not chemicals, they are forces. So now let's turn back to our assignment on mastering chemistry and answer number 2A. Please stop after answering part A. When you're done, come back to the lecture. So science has 5 basic characteristics. Science must be testable, it must be reproducible, it must be explanatory, predictive, and yet tentative, right? Tentative is the one that we sometimes forget. Sometimes we only understand science through which the lens that we look at it, meaning at what level of instrumentation or precision or accuracy in terms of our technology do we have, right? So science can change, even though should be reproducible and predictive. But once we understand something at a deeper level, all of a sudden its meaning may change, right? So tentative, super important. So when we start thinking about science, we always think about the scientific method or scientific reasoning, which if you recall from middle school, grade school science, the scientific method or cycle follows along this path of observation, questioning, hypothesis, a prediction, an experiment, and a result. And often those results are then observed and we start the cycle over again, right? The result saying, does our hypothesis, is our hypothesis true or not, or is it more complex? And if so, what does that mean? What are our new questions? How do we modify or develop a new experiment to then again test these new questions? So the scientific method, by definition, is a set of general principles that help describe how scientists think, right? Help, right? It's not all inclusive and it's not linear, right? We can go back and forth in all different directions. But in the basic 4 steps, we're going to one, make observations about nature and ask questions about what you observe. When an observation always seems to be true, it may be stated as a law that predicts that behavior and is often measurable. Number 2, we often then propose a hypothesis, which gives a possible explanation for that observation or law. And then 3, we will perform experiments to help find the relationship between the hypothesis and the observation, right? That's our if-then or cause and effect, right? Once we understand that, we can control things, right? We can develop technology based on those results. So after our experiment, we then observe the results and hopefully make a conclusion as to whether the hypothesis may be true or false after analysis of those experiments. Okay, if we go through this cycle over and over again enough and it's always upheld, then all of a sudden our hypothesis does become a law, right? But if our hypothesis is modified, should be modified if the results of the experiment do not support it, right? You can't just keep trying to force the results to be what they are. You have to modify your way of thinking about that observation by modifying your hypothesis. So everybody uses the scientific method, not just scientists. So in our daily lives, we are often using the scientific method. So for example, suppose you visit a friend in her home and soon after you arrive, you begin to sneeze. You observe that your friend has a new cat and you ask yourself, why are you sneezing? And you form a hypothesis that maybe you're allergic to cats, which would be totally tragic. I would hate that for you. Nobody should be allergic to cats. Cats are amazing. So, in order to hopefully disprove your hypothesis, you begin performing experiments to test your hypothesis by visiting other friends who also are amazing cat owners. If you sneeze after leaving the other homes with cats, then maybe you can come to the conclusion that your hypothesis is correct and you're allergic to cats, which would be just tragic. I'm so sorry. There are things you can do. Go visit your ENT and talk to them because you definitely need to figure this out. We can also apply the scientific method in other ways in our daily lives, and in our careers. So here's another example. So observation. A hiker notices several fish floating at the edge of a river and notifies a river keeper. Hypothesis. The river keeper contemplates potential toxins or changes to the environment due to a hazardous waste release upstream from some sort of industrial partner. Experiment. The river keeper performs some site tests to confirm or rule out potential environmental hazards and collects a fish and water sample for lab testing. Analysis. The river keeper reviews the results of those lab testing. And in conclusion, they determine whether the results confirm or dismiss the initial hypothesis, right? So again, perfect example of how we can use scientific reasoning in our career if we happen to be a river keeper. All right, so now let's go back to masteringchemistry.com. It's your turn. And finish question 2 by answering questions 2B, 2C, 3A through C, 4, and 5. All right, pause. And when you're done, come back to the lecture. Great. All right. So I'm glad you answered those questions, and maybe you have a little more understanding of scientific method and scientific reasoning under lots of different lenses and contexts. So now it's your turn. Take 3 minutes and write down and contemplate a time when you use the scientific method in your own life. Then share that to the discussion board under Module 1, applying the scientific method in real life. Be sure to look at your peers' posts as well. Again, the more examples we have, the more intentional we are with our learning, the better we will understand and succeed in this course. So what is a scientific law? So a scientific law summarizes large amounts of scientific data and provides descriptions of natural phenomena such as the law of gravity, the law of conservation of mass and matter, etc. And many scientific laws, because they tend to be highly validated and are always true, many scientific laws can therefore be stated mathematically. A scientific theory is a set of tested hypotheses that explain natural phenomena. Scientific theories are the best current explanation for natural phenomena, and theories are always tentative and may change as observations of nature change, right? So it's sort of, if we think about our hierarchical level of data-driven statements, hypotheses is at the bottom, right? Maybe not as much data to support that hypothesis. But once we develop enough data and that hypothesis is validated over and over and over again, then we bump up to a scientific theory. And then once that's been proven without a doubt, then a scientific theory may become a scientific law. However, most of science is highly limited. So science is limited to studying what is observable. And again, that is going to be a limitation of our technology, as well as processes in which variables can be controlled, right? So sometimes we can't control all the variables in an experiment. And what we may see happening may not be a result of our experiment, but a result of humidity or pressure or temperature or something else that we're not accounting for. This is why science using human subjects can be really challenging because humans can have lots of different variables that's hard to account for. Science and technology are interrelated. They both involve taking risks and benefits, and so often there's a risk-benefit analysis in determining whether or not an experiment or a field of study should be pursued. So for example, when we think about CRISPR technology, which is genetic editing or genetic modification, we always have to ask ourselves, yes, there's significant health benefits, but what are the social, economical, moral, ethical costs if that science were to be mistreated or misused? So when we look at weighing the positive benefits versus the negatives or the costs, we call that a desirability quotient, or DQ, right? If it's large and positive, then likely that is science we should pursue. If it's very small and negative, then maybe we should not go down this path. Maybe it's too risky. Now, science can help us address a lot of things. So science can be used for political action. So for example, Rachel Carson was an author and environmental scientist who exposed pesticide industry and agricultural use as poisoning the rivers and seas, or rivers that eventually dump out into the ocean, and it actually caused a lot of uproar in the late 1950s, 1960s with her book Silent Spring. And she actually caught a lot of political and industrial backlash over this, but she persisted in her movement to raise awareness of the use of pesticides in agriculture, and that rain runoff that would then wash those pesticides into creeks, streams, and rivers, and killing fish and insects that those creeks and rivers need to grow and thrive. And it did eventually lead to stronger EPA and FDA regulations after the release of her book. Science can also help us solve societal problems in economics. So applied research is often involving studying a specific problem in industry or environment. So a beautiful example of this is George Washington Carver. He had a lot of inventions based on science. That is working with peanuts. Again, a beautiful example of applied research. He developed more than 300 products as a result from peanuts, which was a huge economical boost in the time. We can also use research or science to help us build foundational basic research knowledge. And this is, basic research involves the search for knowledge for its own sake. The findings of basic research may someday be applied to a specific problem in industry and environment, such as what George Washington Carver did. So a great example of this is Gertrude Ellison's work with purines, and their role in the cell is an example of basic research. So purine is one of our building blocks for DNA or nucleic acids. So without the understanding of purines, we did not understand DNA well, and DNA replication. And so again, foundational knowledge that was important as we continue to grow and create applied science. Another field of chemistry that I want to touch on is green chemistry. So green chemistry emphasizes the use of materials and processes that are intended to prevent or reduce pollution at its source. And its foundation is in sustainable chemistry, right? So sustainable chemistry is designed to meet the needs of the present generation without compromising the needs of future generations. So throughout this semester, I will keep touching base on green chemistry principles as they apply to the content that we are discussing, in hopes that even though you guys may not be going into a chemistry related career, you will all be working either in an industry or a field or as a citizen in a community. And it's important for you guys to be mindful of green chemistry principles because, again, all matter, or chemistry has to do with all matter, right? And so all of our products, all of our processes, all of our food, all of our energy touches chemistry. And chemistry is going to influence that. And so hopefully all of these industries and fields are utilizing green chemistry principles. And if not, it is usually up to you as a member of the community, whether that's an employee, a resident, a voter, to help encourage those people in power and administration and with those authoritative decision-making capabilities to utilize green chemistry principles. And you'll get lots of examples of this as we move through the material. All right, so let's pause, go back to masteringchemistry.com, and now work through questions 6 through 9. When you're ready, come back to the lecture and we'll continue. Okay, so now that we sort of set the scene or the stage, so to speak, for what is chemistry, what is science, what is the scientific method, what are sort of the different types of science versus applied basic research or political action science. And we also talked a little bit about green chemistry. Now let's talk about some of the math skills that are going to be important for any career as well as in this class. So throughout this class, in order to succeed, you need to be comfortable in analyzing graphs. And that's also important in any career field you're planning to go into, right? So analyzing graphs means interpreting data. That can be assessing trends in the media, weather, finance, populations, and predicting the future, right? Being able to analyze graphs will allow you to do all of that. You also need to be comfortable in converting units. Not only is this important in chemistry, but it's also important in culinary fields, landscaping, interior decor, construction, nursing, all of those things. Comparing values, right? So understanding not only the magnitude of a value or if we're having to compare apples to oranges, how can we do those conversions so that we're all on the same page? Again, this is going to be important in comparing to norms, right? Is this above average, lower than average, equal to average? Is it way above, or is it just marginally inflated, right? All of those things are going to be important. And it's also important in inventory management, right? So that can help you predict, oh, are we getting more products being sold or not enough products being sold? Are we getting, anyway, inventory management. All right, making solutions. That's something we're going to talk about later on this semester. Again, that's going to be important in the culinary fields, waste management, and construction. And then solving equations is important everywhere. That's going to be important in budgeting, building credit, calculating customer payments. So, get comfortable having to solve and rearrange equations and plug known values into unknown variables. Okay. And I mean, I love math. I see the world through math. It's just how my brain works. However, I recognize not everybody is comfortable with math, and that's okay. You don't have to be super comfortable with it, but you at least have to know how to utilize some of these basic skills we're going to go over. If you're feeling really weak in math, there is a mathematical conversion workshop activity in this module that I would encourage you guys to look at and do if you need extra help. All right, so some of the key math skills we need to be comfortable with. The first one is identifying place value. So if you remember, anything to the right of the decimal place is going to be a fractional or something that is less than 1. So between 0 and 1. Anything that is above or to the left of the decimal place is going to be numbers that are 1 or greater. And so if we think about our place values, right, we have our first place values in the ones, then the tens, hundreds, thousands, 10,000s, 100,000s, so on and so forth. When we go from the decimal point to the right, it's going to be the tenths, hundredths, thousands, okay? In chemistry, we're often having to deal with decimal numbers, fractional numbers, and we're often having to deal with really, really large numbers. So we'll talk about scientific notation and really, really, really small numbers. Again, decimals being important. You also need to get comfortable thinking about using positive and negative numbers. So there are some basic rules I just want to remind you guys of. Number one, when two positive numbers or two negative numbers are multiplied or divided, the answer is always positive, right? So if you have two positives, it's a positive. If you have two negatives, the negative signs cancel out and you also end up with a positive number. Whether you are multiplying or dividing, this rule stays the same. When a positive number and a negative number are multiplied or divided, then the answer is always negative, right? So if you have one positive and one negative, then the negative sign dominates and you end up with a negative number regardless. Okay, so again, if you have two negatives, it becomes a positive. So this is an error right here. If it's -6 divided by -3, it should be +2. I think what they intended to do was to flip and say -6 divided by 3 instead of this. I think they meant to take this negative sign off. So it was just an error in this slide. Okay, when two positive numbers are added, the sign is always positive. However, when two negative numbers are added, the sign of the answer is always negative. So for example, +3 plus +4 is 7, and -3 plus -4 is -7. So if you are adding two positives, two negatives, then the sign does not change. When a positive number and a negative number are added, the smaller number is subtracted from the larger number, and the result has the same size as the larger number. So for example, if we have positive 12 plus negative 15, then the answer is going to be negative 3, or 15 minus 12, since 15, which is 3, and since 15 is the larger number, then we have a negative 3. Okay? When two numbers are subtracted, change the sign of the number to be subtracted and then follow the rules for addition. So for example, if we have 12 minus plus 5, that's the same thing as saying 12 minus 5, which is 7. However, if we have 12 minus negative 5, then these two negative signs cancel out and we end up with 12 plus 5 and we get 17. Again, if we have negative 12 minus negative 5, the two negatives cancel, we get positive. So we have negative 12 plus 5 gives us negative 7. And then if it's negative 12 minus positive 5, then that's the same thing as saying negative 12 minus 5, which equals negative 17. All right. Get to know your calculator. Remember to use the change sign button in order to make a number negative, not the subtraction button, right? If you use the subtraction button, your calculator does not know the order of operations. It does not know the rules here of, 12 minus negative 5. If you just said 12 minus minus 5, you'd just probably get an error, right? So make sure you use the change sign to go from positive to negative, not the subtraction. It can also help to use your parentheses in order to help it understand order of operations. All right. So here's some examples of how to plug that into your calculator. I would encourage you to pause here and sort of work through these examples with your calculator. Okay, you will need calculators for your tests, and so it's important that you practice that. Okay, calculating percentages. So to determine a percentage, you divide the parts by the total whole and multiply by 100%. So for example, if you have 8 chemistry books and 32 books total, that's going to be 8 divided by 32 times 100% gives you 25% of your books are chemistry books. You're doing pretty good if 25% of your books are chemistry books. I'd be pretty proud of y'all. If the percentage of red balls is 5, it means there are 5 red balls in every 100. So we can work forward and backward, right, in thinking about sort of these equations and calculating percentages. All right, so now let's go back to our Mastering Chemistry assignment for Chapter 1, Part 1, and now answer questions 10 and 11 for me. When you're ready, come back. All right, solving equations is another important skill in chemistry. And often to solve equations, we have to first rearrange the equation in order to solve for our unknown variable. So to rearrange equations, the first thing you're going to do is you're going to place all like terms on the same side. So if we're trying to solve for x, we want to get all our x's on the one side and all our non-x's on the other side. Once you've done that, then you're going to isolate the variable you need by often having to divide both sides by the number that is in front of that variable. Then you can always check your answer by plugging something in for x in order to see if you get that right answer. Okay. So your turn. Can you solve this equation, rearrange this equation for P1? So this is the an ideal gas law equation that we'll learn about later in the semester. But here we have P1 V1 equals P2 V2. If we want to solve for P1, then all we have to simply do is divide both sides by V1 such that we end up with P1 is equal to P2 V2 over V1. As long as P1 is by itself, we have solved or rearranged the equation. All right, again, another important skill is going to be interpreting graphs. So if you remember, a graph will represent the relationship between two variables, often a dependent and dependent variable. It contains two perpendicular axes that represent one of the two variables. We have a horizontal or x-axis here. and a vertical or y-axis here. So for example, the line on this graph indicates a direct relationship, meaning as the horizontal axis increases, so does the y-axis, and it's increasing proportionally, hence why it's a direct relationship. That the volume of a gas in a balloon increases as temperature increases. This graph can then be used to help us determine the volume of a gas at various temperatures, right? So for example, if I said, what is the volume of this gas at 35 degrees Celsius, then you would look at the graph, go kind of halfway between 20 and 40, extrapolate up to where you see your data point, or that relationship, that red line, and then you can extrapolate over to your y-axis, and you would look at that and say, all right, well, that's halfway between 24 and 26, so I would say that's about 25.0 liters. Okay, if we were to fit this line to a model, we would actually have numerical values in an equation that we could use to quantitatively solve for that value, right? So that instead of guessing it's 25, we could actually calculate it specifically. All right, so now pause and let's go back and answer question 12, which is the last question for this unit's assignment. Okay. Oh, well, maybe I lied. No, it is. It's the last question, but I do have one more thing I want to talk about, which is understanding scientific notation. So like I said, in chemistry, we often are having to deal with very, very, very large numbers and very, very, very small numbers. So in order to efficiently or effectively analyze those numbers or compare those numbers or do math with those numbers, we often have to use scientific notation. So we often use scientific notation when working with very large or very small numbers. Numbers written in scientific notation have two parts. We have a coefficient, which is the numerical value in the front, like this, 2.4, and a power of 10, like this, which is 10 to the 3. So for example, to write the number 2,400 in its correct scientific notation, we're going to move our decimal place between the first non-zero digit and the second non-zero digit. So we're going to go from the decimal place, and we're going to go 1, 2, 3 values in. Our coefficient then becomes 2.4. Because we move our decimal place 3 times, 1, 2, 3, the power is then going to be 10 to the 3 because we move the decimal place 3 times, 1, 2, 3. And it's a positive 3 because we're moving the decimal place to the left. You'll see an example of what happens if we move it to the right. Okay, so therefore we would then write the product of the coefficient multiplied by its power of 10. So 2,400 is the same thing as 2.4 times 10 to the third power. Okay, so again, we're going to move the decimal point until there is one digit to the left of the decimal point. Okay, which means we can either move it to the left. If we move to the left, our coefficient becomes positive. However, sometimes we need to move our decimal place to the right. When that happens, our coefficient is negative. So for example, if we are going to write this number in scientific notation, we're going to move our decimal place 1, 2, 3, 4, 5 times. So the number becomes 1.56 times 10 to the 5th. Again, we moved it 1, 2, 3, 4, 5. Okay, because we moved it to the left, our exponent went up in number, so it's positive 5. However, if we needed to convert this fractional value to scientific notation, we would have to move our decimal place to the right, and we would move it 6 times. So 1, 2, 3, 4, 5, 6. Again, our decimal place being after the first non-zero digit. That's going to give us 5.3 times 10 to the negative 6. Again, we had to move the decimal place to the right, so our exponent goes down 6. All right, so now I want you to practice I'm sorry. So we do have one more question, question 13. Again, feel free to reach out to a partner in class, or if you're doing this, you could be sitting and watching this lecture video with a friend, and that would be great. I definitely encourage you guys to do that. But if you're working alone, that's okay too. If you have questions, write them down, share them in the discussion board. All right. When you're done with question 13, come back. Okay, so I'm so glad that we finished this first unit. There is a homework assignment that I want y'all to complete, and it is working on some key math skills, solving equations and percentages, and also looking at graphs. It's a dynamic study module, so it's one of those like, if you're doing really good on this concept, then you're going to move through faster. But if it senses that you're struggling with this concept, it's going to ask you more questions until it feels like you're more confident and you're meeting those learning objectives. So key, don't rush through it. Don't make silly mistakes. Take your time. This is actually work smarter, not harder. So if you take your time, it'll actually probably take you less time to complete this assignment. For lab, we will be practicing scientific reasoning and mathematical skills with Virtual Lab 1 Density. Okay, so you'll see that. Again, because we are compressing 15 weeks of class into 4 weeks, we'll have 2 lab assignments a week. So the first lab assignment is going to be density, and the second lab assignment will be building an atom. All right, so I hope you enjoyed this first lecture. Again, feel free to reach out. I'm super approachable. I will not judge or criticize or make fun of you for asking questions. Please ask me questions. It's what I get paid to do, is help you manage this course and get through this material. My goal is for everybody to get an A. I want everybody to get an A. I don't want anybody to fail. I don't think any professor has a goal to fail students, but I think sometimes students feel that way, and I don't want you to feel that way. So if there's anything I can do to make you feel more comfortable and confident, please do not hesitate to reach out. Another thing I would love for you guys to do, if you have not done so already, is go back to our course Canvas page. At the very top, there's this Getting to Know You survey. Please fill it out. I love to get to know you guys and learn more about you, and also learn sort of your preferred name, preferred pronouns, all of those things, so that I can reach out to you in a way that is comfortable for you. All right. So it was great getting to know you, and I will see you in our next lecture. All right, thanks. Bye.